Hello Mathemaniacs, I'm the Edumacator. First off, I wanted to apologize for the lack of a video last week. As it turns out, Billy was not quite up to the task of getting the video done on his own. But it is somewhat understandable given the technical difficulties that occurred.
And this is harder than it looks.
So, without further ado, let's discuss order of operations. First off, what is the order of operations and why is it so important? Basically, the order of operations is a guideline for evaluating mathematical expressions. In other words, if you have a problem that involves different operations like division and subtraction and multiplication, or any of those other operations, the order of operations tells you which ones to do first in order to find the correct value. The reason we have this is for mathematical consistency, because if you do the operations in different orders, you don't always get the same answer. For example, take 4 plus 4 times 4. What's that equal to? Well, if I multiply first, then that gives me 4 times 4, which is 16, and 4 plus 16 is 20. However, if I add first, then that gets me 4 plus 4 is 8, and then 8 times 4 is 32. So 20 and 32 are not the same number, so one of these approaches must be wrong. You ever seen one of those math problems on Facebook where you've got a whole bunch of people in the comment section that are saying, like half of them are saying it's this thing and half of them are saying it's another thing? Most of the time, that sort of problem involves order of operations. And the reason some people have it wrong is simply a lack of understanding how the order of operations work. Now, there's lots of different memory tricks for remembering the order of operations, and we'll talk about those later. But what I want to do first is give you the one important rule to always remember about order of operations. Okay, ready? You always do more powerful operations first. Now, what do I mean by more powerful operations? Well, let's take something like 4 times 5. Now, 4 times 5 means that I have 5 4s, and I'm adding them together all at once. Multiplication is repeated addition. We can kind of think of this like super addition. When we look at it from that perspective, it makes sense that we would classify multiplication as a more powerful operation than addition is. And as a result of this, anytime we have multiplication and addition in the same problem, we always do the multiplication first. So if we look back at our previous problem, the answer would actually be 20, because we do multiplication first, giving us 4 times 4, 16, and then 4 plus 16 is 20. Now, where do subtraction and division fit into all this? Well, we talked about in previous videos how subtraction is just addition in disguise, and division is just multiplication in disguise. We have division and multiplication in the same category, and then a tier below that, we have subtraction and addition. So anything in this tier we're going to do before something from this tier. Are there other tiers, more powerful operations? Well, there are. The most common example would be exponents, or powers. Exponents basically work under the same principle that we established earlier. Whereas multiplication was repeated addition, exponents are repeated multiplication. If I have something like 2 to the 4th power, that means what I have is 4 2's all multiplied together. So exponents would be super multiplication, which puts them in a higher power tier than multiplication. So that would be somewhere up here. Which means that if we have powers and multiplication in the same problem, then we're going to do the exponents first. And we could keep going and see what repeated exponents look like, but that's a video for another time. Now, what would happen if we had two operations that are in the same tier? If this is the case, then we carry out the operations in order from left to right. So if I have a problem like 5 minus 4 plus 3, then because the minus comes first from left to right, I do that first. 5 minus 4 is 1. And then we have 1 plus 3, which is 4. The only exception here is for the exponents. If you have exponents all in kind of a tower here, then you would start at the top and work your way down. So if I had something like 4 to the 3rd power to the 2nd power, then I would start with the top 2, which is 3 to the second power, 9. That brings me down to 4 to the ninth power, which is pretty big. Exponents escalate real quick. So far, pretty straightforward. There's only one other thing we have to worry about. There are certain times where part of the expression is grouped off in such a way that it has priority, usually by something like these, parentheses. In problems like these, parentheses denote an exception to the order of operation rules. If you see something in parentheses, then that operation has to be resolved first before it can interact with anything outside, even if that means that you do something outside of the traditional order. So again, looking at our previous problem, 4 plus 4 times 4. Now, we know that this is equal to 20. However, if I wanted you to add first before we multiplied, then what I could do is put these two 4's inside parentheses. So now I have this thing here times 4. Well, I have to know what this thing is before I can multiply. So I have to add what's inside first. And of course, 4 plus 4 gives me 8, and 8 times 4 gives me 32. So let's recap. More powerful operations first. Operations on the same power level are done from left to right or top to bottom. Operations inside parentheses have priority and can override the first two rules. Now, that is probably the most proper way to classify the order of operations. Most order of operation formulas, for lack of a better word, use something a little bit simpler, and in some cases, not always as accurate. Let's take one particular memory trick, which is often referred to as "Please excuse my dear Aunt Sally," or Pemdas. Each letter in Pemdas tells us which operations to do first in what order. Parentheses, exponents, multiplication, division, addition, subtraction. Now, memory tricks are good, and in a lot of cases, they work just fine. What I wanted to address, though, is there are a couple of issues with this that, if they're not countered correctly, can end up being confusing. For example, in PEMDAS, we have MD and then AS. Multiplication, division, and then addition, subtraction. Now, when it's written this way, it can be possible to sometimes think, oh, maybe we're always supposed to do multiplication before division. But that's not the case. Multiplication and division are in the same power tier. So out of the two of them, you do whichever one comes first, left or right. But when you see it this way, it can sometimes be confusing because you think you have to do multiplication first. And we have a similar problem with AS. If you just look at this, it's possible to get confused and think you always have to do addition before subtraction. And again, addition and subtraction are in the same power tier. And everything in that power tier you do in order from left to right. There is a slightly more subtle issue with this as well. Namely that we use P for parentheses when there's lots of other grouping symbols we have to consider in addition to just parentheses. Any form of parentheses counts, of course, whether it's parentheses like this, curved, or brackets. If I have operations inside absolute value lines, that's a grouping symbol. If I have operations under this thing, which is a radical sign for square roots, then that would also be a grouping symbol. And we have to do that before we can do anything else. It can even happen using fractions. Suppose I have a denominator where my denominator is 4 plus 6. Well, then in order to, before I can evaluate my fraction, I have to do that operation. So that's also a grouping symbol. So limiting our memory trick to just parentheses is a little incomplete. So before I go this week, I want to give you what I think is a much better memory trick for memorizing order of operations than PEMDAS. And as a disclaimer, I didn't come up with this, but I like it. So, GEMMA. Grouping symbols, exponents, multiplication, addition. Now all you have to do is remember that division is multiplication and subtraction is addition. And so you have three distinct groups, exponents, multiplication, addition, with grouping symbols indicating priority. Now, maybe just saying Gemma doesn't really do it for you, so you might come up with a equivalent to please excuse my dear Aunt Sally for this little acronym here. If you think of a really good one, be sure to put it in the comments below, and I'd really love to read them. For instance, if you really have to keep poor Aunt Sally involved in all this order of operations stuff, then you could always say, "Good evening, my aunt." Thank you for watching. If you enjoyed this week's video, please like, comment below, and share the link. If you want to see more, subscribe to our official YouTube channel and follow us on Twitter at Edumacator.